Hello. Okay, welcome to this assignment 1 help session. If you can hear me clearly, please let me know in the chat. If you cannot hear me clearly, please let me know in the chat. Give me a second just to make sure that you can hear me before I keep talking. So anyone that hasn't used YouTube chat before, you do need to open up the link in YouTube. You can't watch it from LMS, as you will not have access to chat. So if you click it and open it up, then you can start using the chat. Hopefully you can hear me. Just type in the chat if you can hear me or not. Awesome. Okay, so what we're going to go through is the assignment. I've got the whole assignment here, and we'll go through it step by step. I'm not going to give the solution away, but this should help quite significantly in getting it done. So we'll go page by page. The first page is fairly obvious. The one thing that I will point out on this first page is this here. You do have to use the Unix server, and you do have to use CS5. Make sure if you're using a different program at home that you do make sure that it works on CS5 before you submit, because we are using ANSI C, and so certain features in later versions of C won't work, and it's expected that you're using this version. Okay, so if you are using something different at home and you're not using the Unix server, make sure that you do check that it works. We should all be using Notepad++ or something similar, and we all should know where the submission is on LMS. If you don't, just ask in the chat. We can have a look at that too. With the submission, there is only one file that we want submitted. We do not want an executable. We want a C file. Make sure that it is a .c file. Make sure that there is text in it. Do not accidentally submit the executable. We cannot do anything with it. Okay? And once the submission closes, we can't reopen it. So double, triple, quadruple check that it is a .c file. Okay. Once again, there is no late submissions unless granted by the lecturer, and with that, you do need to let us know a couple of days before. Okay. Academic integrity, I think I've talked about that too much, but it applies. And now we start the assignment. So in this assignment, we're going to do some basic mathematics, and we're going to convert degrees to radians and radians to degrees. Now, the math for this one isn't too complex. We have degrees equals radians times 180 degrees over pi, and we have radians equals degrees times pi over 180 degrees. Now we've got to keep in mind that this is mathematics at this stage. It's not C code. This symbol here is equals at this stage. And we have pi to 6 decimal places. And this is important also. Okay. Now, some students I noticed in the labs may have not seen this dot before. The dot is just multiplication. So you can see this as radians times 180 over pi. Okay? All right. If there's anything that you want clarification on, just put it in the chat and we can go over it in a little bit more detail. Just let me know. This is probably the easiest part of this stage, and then when we get to the more difficult parts, if you want me to slow down or repeat anything, just put it in the chat. It's perfectly fine. All right. So the problem. So with our C codes and our assignments and our labs, we are always solving a problem. There's no point writing code that doesn't solve anything. And the problem we're trying to solve is to create a program that allows the user, this is a big keyword, and you'll see why this is a big keyword later on, to create a table. Okay, we want a table of degrees to radians or radians to degrees. Okay, formats and steps of deciding the program. This user is very important. When we say the word user, it means that the user can basically put anything into our system and should be able to get a result out. This is different than, say, the first lab we did where we hard-coded values. Here we shouldn't be hard-coding any values at all because the user may put in 2, 10, 100, 1,000, whatever they decide. Now, there are some limitations on what the user will enter, just because we haven't learned how to deal with them yet, but it is a user, and so you shouldn't be writing up any tables by hand because there's, for degrees, there's 360 different options they could choose. For radians, there's quite a few more options they could choose. All right. The table is also important. That's our output. That's what we want to see at the end of this. All right. First things first. This here is extremely important, and you do get marked on the formatting for this. Make sure that it does print it. I've seen a couple of people already that have submitted early, just putting this as a comment. When it says prints to the screen, it's talking about printf, okay? And because there's no variables here, we can write this directly to the screen. So you can write a star, you can write whatever characters you like and print out your student number, your name, and the word assignment 1. Make sure you do replace this with your student number and your name, and don't write exactly what's there. It has been done in the past. All right, it has to be your name, okay? So this here isn't dependent on any variables, so we don't need any more arguments to our printf, meaning we don't need any commas, okay? We're just printing a string literal to the screen. So exactly what we want to print will be printed directly to the screen. So that's the first step, and this will basically be the first thing that we'll have at the start of our main. Now, to do any printing or scanning, don't forget that we need some way to have input and output to our program, so we will need the standard I/O library, okay? And you need to make sure that you include this. All right, once you've done that, first thing I would do is compile, check that there's no errors, and run it. And all you should see is your student number, your name, and assignment 1 to the screen. And this idea of compiling often is extremely important. It means that basically you won't have to go back, try and scour through code, trying to find a mistake. Rather, you can solve the issue as it comes about. All right, I'll leave that there. So once again, this shouldn't be in a comment, it should be printed to the screen. The next part is that it asks the user which table they would like to create. Now, when we're asking the user, we're doing this through the screen. And to do things through the screen, once again, we're using printf. Now, you may want to break this into multiple printfs. You may do it in a single printf. That's up to you. Once again, here we have no variables. Okay, it's just straight text. So we can print this text just directly to the screen. We then have the next part. The program accepts an integer value entered by the user. Now, one important thing here is to note is that you can assume here that the user will always enter an integer value. So unless you're doing the bonus, the user will never ever enter a or hello or anything like this, okay? They won't enter exclamation mark, they won't enter anything like this at all, and you're guaranteed that they won't enter that, okay? So you do not have to worry about that. What they will, however, is enter any integer. So they could enter 10, they could enter 100, could enter 462, they could enter any integer value, okay? This could also be a negative value as well, okay? And this is why dealing with the user is important. We don't know what they're going to enter, and so we have to allow our program to work for any case. And this is why programming is so versatile. So we'll get rid of this. Okay. Now, we've learned two ways so far to get values from the user. We've got either scan formatted or we've got get car. Now, the get car function gets a character. Unless you're doing the bonus, it's probably not very useful because you're only looking for an integer. So you're probably not likely to want this. Okay? You're probably wanting to use the scanf function. Now with the scanf function, we have to think about how we want to accept an integer. So we have a bunch of different format specifiers, such as %d, %f, %c. Okay? And we need to choose the appropriate one. Now, you can assume that everything is in decimal, so you don't need to worry about hexadecimal or octal. It will work anyway, but we're not concerned about that. All right? So with your format specifier, choose the appropriate one that will accept a integer. Now, with scanf, the first argument is the formatted string. Now, unless you're doing something where the format has, for example, commas in it or spaces, etc., most of the time you're just going to put directly a particular format specifier in here with no extra spaces and no extra characters. Okay, and this is the same as you're doing in the lab, and I'll leave this for you to work out what goes there. Now, on the other side, we need a variable to store the result. But as we saw in the lab this week, when we use scanf, okay, when we use scanf, we have to use this ampersand symbol, and this means address of. We don't really care about what this means yet, and we only see it whenever we use scanf for now. Okay, we'll learn what this means in about 2 weeks' time. All right, so every time you use scanf, just remember, okay, I need my ampersand. Now, let's look at a different problem quickly. So let's say I wanted to get a floating point from the user. So I'm not doing this example, just so we can have a look at scanf with a completely different example without giving away this solution. So if I want to accept a floating point value from the user, I'd first need to make a variable to store that result in. So I might just call that result. Okay, your variable will probably have a meaningful name to this. And then I would just have scanf %f because I want a floating point, and then ampersand result. Okay, so make sure that you first create a variable to store that value. Okay, now for me, in this example, I'm using floating point. In your example, you will need a suitable integer type. Okay. Now, with these variables, you can think of them as just storage places. You think of it as a box to store things in. So we'll call this box, it's labeled result. Okay, and inside that box, it stores a particular type of variable, and this one, it stores floating types. Okay. For your one in your assignment, you're going to have a box, whatever you call it. Okay. So it might be called choice because you're making a choice here, or something similar, type of table, or yeah, some type or something similar, something meaningful that basically expresses the user's choice here. And you're going to store that result here. Okay, we do need a storage space if we're going to use scanf. All right. Now, what we're going to do is when you first do this assignment, I would skip this A step. Okay. The reason being is validation should basically be done last. Try and get the program working, and then we'll come and validate it. All right. So don't bother doing this step yet, okay? Because this is checking if the user entered an invalid value. We'll just assume that they entered a valid value for now, and we'll come back to that at the end, right? So when designing your program, try and get the most basic things working first, rather than your validation and anything extra or features, as lots of people like to put it. So we're going to come back to this. Okay, we're going to ignore this for now, because if you are designing the code, you should do the same thing. Is ignore this validation. We're getting an integer, and we just assume for now that it's always going to be a 1 or a 2. Okay? So we'll come back to that at the end. All right, and this is important in how you go about solving these problems. Okay, think about not just going step by step by step. What's the most important thing to do first, and what should I leave till the end? Get the base functionality working first. All right, so we'll come back to that, and we'll go to step 4. Now, we just had the user on the console, okay, enter either a 1 or they might have entered a 2. And we put that inside some kind of box known as a variable. Okay, so we have our variable. Now, your variable name is going to be a lot more creative, but I'm going to call my variable bar. Okay, and because I want to store an integer, it's going to be an int type. I will let you write the declaration for that, okay? And obviously come up with a better name. I'm not going to give you the name, okay? And in there will either be a 1 or a 2, okay? Remember how we said at this stage, we're only expecting 1s or 2s, okay? So given, let's say there's a 1 in there, okay? So we've got a 1 in this storage space. Okay. Now, obviously, this is a representation. If it is a 1, we should do this step 4. Now, the only other case here, okay, is a 2. It can't have any other value because remember, we've got this validation up here that we haven't done yet. Okay, so if they enter a 2, then we go here. But there's no 3. There's no 3 at all. So this is called a binary case. So if my var is 1, else if my var is 2, there's no other cases after this. There's only 2 cases that exist. So even though it's written there, you should be able to recognize that this is kind of redundant. Now, it'll still work, but you should be able to pick up that if it's not 1, then it's 2. And so we can pick up that we don't actually need this. Okay. So now we'll go back and we'll have a look at this. So if the user enters a 1, okay, so we've seen our if statements already, and we can check if the value is 1 using our logical expressions, and we can use equals, if we like, to check if our variable equals the value that we want it to. If it does, then we do what's between the braces. So if this is true, then we do what's here. Okay? And that means that all of the stuff in here has to be inside of these braces. Okay? And what we need to remember with these braces, and we can look at the last page of our reference guide if we're unsure, is that we need to tab in when we reach one of these, and we need to tab back when we reach the closing brace, meaning that all our code will be here. There should be nothing in this section here. Okay? All right. Ooh. So we're now in this A section. And there's no B this year, so that's it easier. All right. So we're inside this A section. Now this might make it bigger. Let's just delete some of this stuff. Excellent. Come down a bit across. All right. So now we should be inside some braces for step 4. Okay, so all of this stuff here has to go inside of these braces for our if. Okay, if some condition, okay, that's for you to work out. You're giving it away anyway. And then inside that, you're going to tab in. Okay, indentation is very important. Okay, and the rest of the code is going to go here. Now, the first thing here is the program accepts an integer. Oh, wait, sorry. Skipped a step. If they enter a 1, the program should ask the user for a value between 1 and 359. Now, we've seen this already. The program asks the user what table they'd like to create. The program asks the user what value they would like to enter. These aren't very different. This is just straight text. And so we know that we'll need some kind of printf here to print out some text to the user. We'll get to validation last. It's the least important thing. All right. So we've got this printf, okay? And it's going to print to the user, please enter something, okay? We then have this, the program accepts an integer value between 1 and 359. However, you can see this blue text. You can assume here that the user will always enter a valid value and an integer. So you're guaranteed that they're going to enter 1 to 359. They're never going to enter 360. They're never going to enter 361. They're never going to enter -2. Okay? So you're guaranteed of that. You do not have to worry about that case unless you're doing the bonus. Okay? All right, and they're not going to enter a letter. They're not going to enter a weird character or anything like that. All right, so you don't have to worry about that at this stage. So the program accepts an integer, and we've seen how to accept things before using scanf. Okay, now if we're going to scan, it means that we need to store something. So it means that we need to create a variable somewhere inside here, maybe here. Okay, so we need to declare a variable so that we can store the result of this scanning. Okay, so somewhere above the scanf, it might be before or after the printf, it really doesn't matter, but it has to be before the scanf. We're going to create a variable, okay, for storing this value between 1 and 359. Now, given that you ask the user for the step size, it'd probably be a really good name to call this variable step size. We know what type it is as well. Okay? So we know the name of the variable probably should be called step size or something similar, or size or step. And we know it's going to be an integer. Okay? And we know the most common and most useful integer type is going to be our int. All right? So we know that you're going to declare an int and give it a name here. And then you're going to get its value here, okay, in the scanf. All right, so let's continue. This is probably the biggest part in the assignment. And how you do this will really affect your marks. You do need to use a for loop here. It's in the marking guide, so don't try and do it any other weird way. Now we're going to go and look at for loops before we have a look at this. Okay, let's find some empty space. So we're going to start with a for loop. And we'll look how it works. Give me a second. Right, I'll make this a little bigger, just so I don't have to do so many loops. All right, so I've got a simple for loop here, okay, and I'm actually going to draw the flow diagram for this as well. So first things first, we've got this part of our code. Now usually I don't actually need this in a flow diagram, but I'm going to put it there anyway. The next thing we have in our for loop, use the lab. You can use the lab rooms whenever you like. If you've got card access, you've got 24-hour access. If you don't have card access, go contact Somna, but you do have access from 9 till 5 anyway. And if they're locked, just speak to one of the staff members. So the first part of the for loop is always this part here, okay? And this is called our initialization. Okay. The second part of the for loop is called our condition. Okay, so this is our initialization. This part here is called our condition. Now, how we know that they're different is that they've got these semicolons here. The next part that happens is the block or the code. I'm just going to call it the block. Okay, and this is the block. And this can be 50 lines, it could be 1 line, it could be 1,000 lines. Okay, so the important thing to note here is that the condition is checked before the block. And a lot of people get confused about this. And the last thing that happens before repeating, oops, and I stuffed it up, is our update. This diagram you need to know off by heart. Okay, you need to know it before the exam very well. Okay, so, and this will just go down. And it's just other code below that. Okay, this here is extremely important. So we've got our initialization, our condition, our update, our block, and then we've also got some other code. Now we also need to add a couple more details. We need to add true and false here. Okay, so it goes down this line if it's true, and it'll go down this line if it's false. So for us, in this particular for loop, our initialization is 4, our condition is I is less than 20, our block is this printf, and our update is this I becomes I plus 5. So we're going to go through this step by step, and we'll see how it works, and then we can apply it to your own code. Okay? The delay is quite significant. All right. So what we're going to do is we're going to go through this step by step. I might just this. A little bit smaller. All right, that's better. All right. So what we're going to do is the first thing that happens, okay, we're currently here, is this int I, which is declaring a variable called I. Now, I might not seem like a very good name for a variable. As we said, give it a meaningful name. What you'll learn soon is I, J, K are actually very meaningful names, and they should only be used for this purpose. I is used for single iteration for loops, so a single for loop. J is used for an inner for loop, and K is used for a triple for loop if you're doing 3-dimensional things. So try not to use these variables unless you're doing for loops. All right, so we've created this variable called I, okay? And it's of type int, all right? And in it currently, we don't know, okay? As we said, if we don't give a variable a value from the start, at the moment, it's just garbage. There's a garbage value in there. If we printed it out after this int I, we just get garbage. And we saw this in lab 1. We then continue and we hit this for loop. Now what happens here is slightly confusing, but if you understand this, it will help you dramatically throughout the whole subject because we will be using for loops quite a lot. So this might look a little bit confusing, but if we go to our flowchart or our flow diagram, okay, and if you go to LMS, up the top you can see flow diagrams and you can get a little bit neater version of this. The first thing is our initialization. Okay, so what happens first is the initialization, which is this part. Okay, and you'll notice that this only happens once. Okay, it doesn't happen multiple times. So the initialization is the only thing in here that isn't looping. So the initialization sets I to 4. So I is assigned the value 4. So now this is no longer uninitialized and it has a value of 4. Okay, so we're at this stage right here, or this stage right here if we're looking at the diagram. The next thing that happens, and this is where a lot of people make a mistake, is that we go into our condition. So our condition says that I is less than 20. So we need to check this condition. Okay, so if we're looking at code, we're currently here. Is I less than 20? Yes, yes it is. Excellent. So because it will follow this true path. Okay? So it will go down here and it will go to the block. Okay, so that means it will do all the code that's inside of these braces. If there's 1, if there's 10, if there's 50, so. All right, so basically what will happen here is, let's pretend we've got a console. It will print out the value I. Remember, we've got one format specifier, so we need one extra argument. The arguments are specified with this comma. Okay, the number of format specifiers, so basically you can come along and count how many percent symbols there are, should be the number of commas that follow. Okay. All right, so we print out our value I, okay, and then we add a new line. So we print out the value 4. Now, after the block's completed and it hits here, it doesn't continue. What it does is it goes back up to this top bit and goes to the update. Okay? So we end up here. Now, I becomes I plus 5. So I plus 5 is 4 plus 5, which is 9, and that gets stored in our variable 9. So we store 9 here. Now, what you'll notice is the next thing it does is goes back to the condition. Okay, so it's a little bit not in the order that it looks like it's in, and this is why for loops can be confusing and why this kind of diagram can really help. So what we're going to do now is check, is 9 less than 20? Yes, it is. So we go down this path again, and we go back to our block, and we print out our I. So we print out 9. We go back up, and we update. So now 9 I is 14. Okay. We then go check our condition, just true. So we come back down, we print 14. We go back up again, and now I will be 19. We keep following this. I is less than 20. So it's true. We print out 19. Once again, we go to the update first. Okay. And we get 24. Now this is also important to note that this value is still in I. We keep going and we reach the condition and we check the condition. Is 24 less than 20? No. So false, and we do the other code that follows after this brace now. Okay. Now for this, we can go back to our problem and see how that fits in perfectly with for loops. So what you can see here is that basically we have the values start at 0. Okay, so we could call that maybe our initialization. They increment by a step value. Maybe we call that an update. While the value is less than 360, maybe we could call that our condition. Okay, so you can see how that fits in perfectly with this. Okay, so it fits in perfectly with our for loop. Okay, so you can create a variable such as, say, int I, create your for loop, and put your initialization So for us, it starts at 0, so I might start at 0. We want to continue while the value is less than 360. So while I is less than 360. And then the last part is going to be incrementing by the step value. So I becomes I plus step value. You can see how this fits in with for loops beautifully. Okay? And it means that if I print I out, it's just going to print 0. If it was 60, it's going to print 0, 60, 120, 180, 240, 300. As it did with our example that I can't find here, the print 4, 9, 14, 19. You can see here that our initial is 4. Okay? In our problem, it's 0. You can see the step value here is 5. Okay? In ours, it's going to be a variable. Okay, here it's a constant. And then you can see that the condition or the ending part in this problem is 20, but for us, it's just going to be 360. So you can see that this small amount of code, even though we're not doing the conversion yet, has pretty much done all of the same thing for our degree part. Okay? And we're using a for loop properly to do that. And this is why it's presented in this way as well. Okay? You need to comment how that's implemented. So we know how to do this degree part now, but we also need to convert to radians. Now, let's go back and have a look at this. Let me just clean up the screen a bit, because it's a bit of a mess. Actually, I'll keep that. Let's get rid of that. And I'll still do it. All right, let's move down a little bit. So, is that on the same layer? Right. So we know that we've got. I just put it there. We've got some variable up here for our step value. Now, one thing to note is in some of the labs, we've been declaring all our variables at the top. But here, we don't need this variable unless we're doing degrees to radians. So there's no point declaring it at the top. We only need this variable, okay, this integer variable, if we're doing degrees to radians. We don't need it if we're doing radians to degrees. So I'd actually declare this step value for degrees here. Okay, so this is where our variable for step size would go. I'm not giving you how to implement that. You shouldn't have to do that. Okay, we then have our for loop. Now, important thing about the for loop. Okay, once again, we have to indent. Okay, and in here, we're just going to print our table. So we know that we need a printf. Okay, you already know how to print this degrees part. Okay, so you know that you're going to need at least 2 format specifiers. Okay, you can work out which ones. You know you're going to need a line in the middle. You know you're going to have to do a little bit of more advanced formatting, like we did in lab week 2. We can talk about that more if you're confused by width and precision. We'll come back to that. And so we need 2 arguments. And we just talked about what's going on. Sorry. Clearer. Okay, so we know the number of percents is the number of commas that follow. Okay. And we know that this first one is just I. Okay, we talked about if we set this up properly, it's just going to be I. This is looking a pretty big mess. I'll get rid of this indenting so a little neater. It's, it's crazy. Okay, so we know that that's I, and now all we need to print. Okay, obviously you need to put degrees here and stuff like that, but I'll leave that to you. Okay. You can do all the formatting. Right, so we need to now print this radians part. Now, how you do this is up to you. You may want to create another variable inside of this for loop. You do need something at the end of this as well, so that you go to the next line. I'll let you do that. Oh, we're going up the top. So now we have to go back to our formula. Stop scrolling. Okay, so we need to go back to our formula, and we need the radians formula. So we need degrees times pi over 180. Now, as we're going to be using pi for both calculations, we will probably define that at the top somewhere, okay? Like you've had in the lab. Okay, because we're going to use it for both cases, we will define it at the top, okay? This one's only used here, so we'll define it between these braces. We'll look at scope a little bit more detail later, and I'll have a talk about declaring variables at the top and not declaring variables at the top in a little bit, right? Okay, now what do we need? So we need degrees times pi over 180. So you could either do this formula here, or you could create a new variable and then just put that variable name here. Okay. Either way, you would get full marks for that. However, and this is what we're going to talk about now, given the question that someone just asked, no, it would not be appropriate to create this variable at the top of your program, nor would it be appropriate to create this variable at the top of the program. When you've got variables that are only going to be used with inside this if, they should be inside this if. When you've got variables that are only going to be used in this for, they should only really be declared within this for. If you've got variables that are going to be used for the whole program, yes, it is suitable to declare them at the top unless they logically need to fit with some algorithm or concept. So for example, for loops, you should never declare the I at the top. You should always declare it with the for loop. If you're going to do an algorithm, you might declare all your variables before the algorithm. Okay? Declaring at the top, because of our programs haven't really had many ifs in them yet, or loops in them, it works so far. But now that we've got different conditions and we'll need different variables depending on the circumstances, no, we should not declare everything at the top. As I said, however, pi we're going to use everywhere, so it makes sense to declare that at the top. But this step size for an integer is only going to be used within this if. The step size for this is going to be a completely different type because here we're using floating point. Okay, so where you declare the variable is important. Okay, in the lab so far, we haven't needed to declare them in their own places yet, but in this problem, we are getting to that stage. Great question. All right, so we've pretty much printed all of our values out. Probably should. Okay, so you've got two options. You create a variable in here and give it the value of the formula using your I. Okay, I is obviously your current degrees value, or you can just stick the formula in here if you are confident in doing that. Okay. All right. All right. There's a couple of things here. So we've done the calculation, we've done that, done that. Now we've got to talk about the formatting. All right. So there is an empty line after the user's input. Now, this one I'm leaving to you. Make sure you do put it in the right place. It's not an empty line after each line. It's right at the end. So you need to think about, does it go inside the for loop, or does it go outside the for loop, or does it go before the for loop? All right? You need to think about where you're going to put this. Right? So you should all know how to do a printf with just a new line. Okay? So you should be able to do that. All right. Let's talk about width, precision, and width. I think you can do single space, then line, then single space. Now, one thing to note for this assignment, for pretty much everything in this subject, the format has to be exactly as above. Okay? Even if it looks ugly, even if you've got a better way of doing it, it needs to be exactly as above. All right. So let's talk about this precision. We haven't really got much more to go on, and then we'll go through the marking guide, etc. What I might do, however, actually, it doesn't really matter. All right. So we're going to look at a completely different problem. We're just going to create, let's say, int a. Actually, let's do. I've got a perfect problem. So let's say I want to print out. Let's say I want to print out 1, 2, 4, 8, 16, 32, 64, 128. Okay. Now, I'm going to use a for loop to do this, and you'll notice that here, oops, I have a space at the front of this, and I also have a space at the front of this. Why does it keep doing that? Okay, so this is called width. Okay, width is the minimum amount of spaces that the number must take up. So here it's 3. Okay, so even though I printed 1, it still takes up 3 spaces. Even though I printed up 32, it still takes up 3 spaces. Print 128, it takes up 3 spaces. Now if I print a larger number, it will just take up more spaces. It's the minimum number. So what we're going to do is we're going to create a for loop. Start at I0. Okay, so we'll just do 0. So that's 8. I haven't talked about I++ yet, and it's a little bit more confusing than you take it granted for. All right, sorry about that. Let's do it this way. Okay, so what I'm going to do here is I'm going to do a printf. Now, I know that I'm going to need a new line. Okay, I definitely know that I'm going to need a new line, because every line we get a new line. Okay. Now, the thing that I want to print is an integer. So I know that I'm going to need %d. To specify the width of an integer, I write the number beforehand. Okay. So this 3 is called the width. So these numbers have a width of 3. And then I'm going to use the math library. So imagine I've got hash include math, and I'm going to do 2 to the power I. Okay. This here will print this table. Okay, so 2 to the power 0 gives 1, 2 to the power 1 gives 2, 2 to the power 2 gives 4, 2 to the power, sorry, 3 gives 8, 4 gives 16, and so on and so on and so on. Okay, so you can see that we get this nice width. So everything lines up. Now, this is called right justification. And if we wanted left justification, so if I wanted it 1, 2, 4, 8, 16, 32, 128, with the spaces on the other side, then I use left justification, in which I put a negative here. Okay? And that is our left justification, and without the negative here, we get our right justification. Now we can see in our problem, we want right justification, so we don't include the negative. We can see that we have a width of 3, so you're going to have %d, so %3d, okay? The next one is your floats. So floats can have a precision, but they can also have a width. So for example, let's say I want to print out the number 2.40 and I want 3 spaces in front of it. Okay, because the numbers that are going to follow, I want them all to fit in to 1, 2, 3, 4, 5, 6, 7 spaces. This is counted in your width, okay? The decimal point is counted in the width. So if I was to print the number like this, okay, I would need to write %7 point. I need to give how many decimal places, which is my precision, and then I need to specify that it's a floating point number. Okay, this is my width, which will add these 3 spaces in the middle, front, sorry, because at minimum it must take up 7 spaces, and this is my precision. Okay, so we know now how to do precision, we know how to do width, we know how to create a line, and do width for integers. And there's an empty line after the table. So as I said before, there's an empty line after the user's input. You need to work out if it goes before, in, or after. Same with this, there's an empty line after the table. Does it go before, in, or after? All right, so I've pretty much demolished step 4 and made a mess of this canvas. Then we've got step 5, which I'll have a quick talk about, and then we'll talk about the constraints. The bonus we won't talk about. We'll come back up and talk about this, right? And then we'll talk about the marking guide. Now, I've just been talking for an hour, so just give me a 3-minute break. Okay? We'll be back in 2 seconds. All right, I'm back. Let me know that you're still keeping up by just typing something in the chat. And we'll continue. All right. It's hard talking to yourself, so the chat helps, even if it's just something, just so that I've got some feedback. Just wait. Make sure that you're up to where I am. Cool. All right. So now what we're going to do is I'm going to quickly talk about this because I've given you most of this. It's pretty much the same thing here, except for this time we're using floating point numbers. Okay, so I'm going to leave most of this to you. What you'll notice is that it asks the user, but this time our step size is no longer an integer, it's a floating point number. So we need to accept it using the scanf differently, and we need a different variable, okay, of a different type to store that into. We then have this program prints a table. We notice that we've got our initialization, we notice that we've got our update, and we notice that we've got our condition here. Okay, so we should know how to create a for loop. Now there is a slight problem that you may face, and so you may want a precision factor. So if you want, have a look on LMS, and there's a guide for how to add a precision factor. This is just because of the way floating point numbers are stored, but try it without it first, just so that you can get it working. And if you notice there's a small little bit of a mistake, where you just want to add it in after you get it working, basically. So this is a big point that I'm trying to push, is make sure that you get the base working before you start adding features and things that will make it better. All right, so add the precision factor after. Then you've basically got the same thing. You've got your width again, and it tells you what the precision width is. You'll notice this time that the degrees isn't printed as an integer, it's printed as a floating point number. Okay, so you'll need a different format specifier, but you've still got the line after the user's input. There should be a line after. I don't know why that's missing, but you can see it in the output anyway. Okay, and you've got a single space, a line, and then a single space, and you've got the precision, and you've got the width. Okay, notice that the width here is 6 and the width here is 4. All right. Now, what you'll notice about this 4 is that, remember, it includes the decimal point, so this is a width of 4. Right? And same with this width of 6, is that it only puts 2 extra spaces in front of 0.00, because this is already a width of 4, and so we just need to fill it up with 2 extra spaces. So I'm going to leave the rest of that for you. Yeah, that's your little problem, and you've got most of it from what you've done already. All right, so now that you've tested it, it's working well, we go back up and we go have a look at this validation. Now, with your validation and how you handle this, it actually can be done in several ways, but there is a more appropriate way to do this, especially at this stage. Okay, so you've got a couple of, we'll go even higher. Whoops, that's not very good. So you've got a couple of loops to choose from. You've got a do while, you've got a while, or you've got a for loop. Now, a for loop is good for when you've got a clear initial update and a condition. Here, we don't really have, we have the condition, but we don't have an initial or an update. So for loop's not that helpful. So we're going to use a do or a do while here. Now, one is more appropriate than the other. Now, a do happens 1 to n times. Okay, where a while happens 0 to n times. So n just meaning any number. Okay. So basically what this means is that the do while will happen at least once, where while will happen 0 or more times. Now, for our problem here, we'll note that at minimum, it will ask this at least once. Okay, so at least once, it will ask, please select the table you would like to create. Degrees to radians or radians to degrees. So whilst you could use a while loop, you probably want to use a do while loop. Okay. Now, let's look at a different problem. Okay. And what I want to do is, let's say I want the user to enter a capital. Well, no, let's not that complex. Let's make them enter a number between 4 and 7. Okay, so we want to printf. Okay, now we're going to store this value somewhere. So I'm just going to create somewhere to store it. Now we are using it after the loop, so I need to actually create it outside of the loop. Okay, and this is important, and we'll look at scope a little bit later. But your variable only exists between these braces. Okay, so if you have a loop, the variable disappears after the end of the loop. And so we actually need it outside of the loop. So we're going to create a variable called var. Okay. And I'm going to ask the user to enter a value between 4 and 7. Okay. What the hell is that? Oh, I don't know what that is. Sorry. Okay, so this here, I want to ask them at least once, and maybe more times if they put something in that's invalid. So I'm going to use a do while loop here. Now, while it might not seem that efficient, at this stage, it's not a bad solution to do it this way, and I'll show you why. Might think it's bad, but it'll still work, and we have no problem with it. So we want to continue going around this loop while they're putting something invalid. So while we probably should collect the value. That would make sense. So we're going to collect the value from the user. We'll just use %d. And we're going to store it in var. So we're going to continue while var is greater than 7 or var is less than 4. Okay, so if var is less than 4 or var is greater than 7, then we can keep going around this loop. Now, we also want to print out a message to the user saying you entered something invalid. So we can put an if statement here and say if var is greater than 7 or var is less than 4, which is perfectly fine. I know that we're checking the condition twice. It's perfectly fine for right now. Okay? And you will not lose marks, and it is not inefficient. All right? What command can be used to terminate execution? We're not using command. Oh, so in Unix, if you've got an infinite loop, just press Control-C, and it'll stop your infinite loop so that you can keep trying. Okay, so Control-C, which is horrible because so many people are used to Control-C being copy, will kill your program. All right, so you entered an invalid value. And we might want to put a new line after that as well. Don't forget your new lines. They're easy to forget, but you'll notice them straight away. Okay. Now, if you prefer to look at the not case, we can invert this whole thing, and we can say, instead of or, we can use and we can say while the is greater or equal to 4 and the is less than or equal to 7, and we can put a not here. Okay? So while it's not these values. Okay, so we can say not the greater or equal to 4 and the less than or equal to 7. Okay? So you can use this to do that first part. Okay? Obviously, you're not going to have a range like I have here. Okay? So here we're using a do while. We use the if just to print out another message, and we continue while it's invalid. Okay? And that's pretty much the whole assignment. Okay? So now we'll just keep going. Sorry if that wasn't as clear. If you want to go over something, it's a long day. All right. Let's keep going. Okay, so pi needs to be specified to exactly 6 decimal places. Okay, no more, no less. This is just because of the way we're testing your program. Okay, the user can select the resolution of the table by selecting the step size. So you don't choose the step size; the user chooses the step size. Formatting needs to be as specified, as I mentioned before. Text to the user needs to be easily understandable. I think we tell you exactly what text to give the user. Yeah, in this one, we pretty much tell you what to give the user, so that makes it easy. Must print your student number. Okay. Types should be used appropriately. This is an important one. So unless you need, for integers, basically you should try and use the int type. There is a special reason for this, which we'll look at when we look at systems. And so unless you've got a special need for a short or a long, you should just use int as your general purpose integer. Even though short stores a shorter number, and you might know that your number is short, still use an int. We'll talk about why later. Same with unsigned. Unless you're told you need unsigned, just use signed, right? You don't need to use functions. You can if you want to. You need to comment significant amounts of code. Someone asked about Boolean variables. We don't use Boolean variables in standard C. There is no such thing. They're very wasteful. We'll look at flags instead in C, which we'll do in the next assignment, and we'll also do in the next lab, I believe. So no, do not try to avoid Boolean variables. We try to use flags such that we pack our variables. We will use some different flags, but no, there's no variable type called Boolean in C. It's a type def. So you should ideally avoid it. You can have a int or something, or a car that acts as a flag for now. If do will definitely execute once. if again do users enter wrong. Yes. So definitely. So in the do while, because it's a loop, there we go. All right. So if we have a look at this example, enter a value between 4 and 7. So let's say they enter 3. So we go down here, the 3 goes into our var. It's not between 4 and 7, so it'll print, you entered an invalid value. It will continue while this is not true. Okay, so it'll go up, okay, and repeat and say enter a value between 4 and 7. I enter an 8. Once again, it will keep repeating while it's not true. If you're talking about the first bonus, if you've got multiple validations, you're probably doing it wrong. The code loop every time the user inputs something invalid. I don't know what you mean by that. Basically, for the I'll talk about the bonus in a second, actually. But the code should only loop here. If this is incorrect, it shouldn't loop anywhere else. And for the bonus here, it should only loop here. So there's only one condition here, and the condition should disappear after this. We don't need that variable anymore. The condition for this should just loop here if you're doing the bonus. Same with here. All right. Bonuses. The bonuses, I've given the outputs. If they don't work 100% for every single case, printed exactly as specified on LMS, don't include them. There is no half marks for them, okay? And if they break what code you've got, you won't get any extra marks, and you may lose marks on your normal task. The bonuses are bonuses, okay? They have to use stuff only been taught so far, okay? So nothing past week 4, okay? And they have to work 100% exactly the way that they're printed on the example output. So if they enter one letter wrong and then you start trying to loop, no, that's incorrect. That's what you're asking. And just as a hint, you don't need multiple flags. Hints. Now, this number of lines of code isn't a measure of efficiency. You're welcome to use this to work out if you're far away. If you're below 30 or you're at like, I don't know, 120 or 150, you might start considering that you've got something wrong. If you're at 80, it's perfectly fine. I wouldn't worry. This is lines of code. It's not lines of comments too. Okay. And we'll talk about the marking. So make sure you do read the marking. The difference between compiling with warnings and compiling without warnings is 8 points or 8%. Okay, so it is significant. It's also 16% of your total mark for this if it compiles or if it doesn't compile. It is a large amount. And if it doesn't compile, you're likely to lose other marks as well. So make sure it does compile, even if it's not fully complete. Make sure at least it compiles. Okay? This is really, really important. The other thing you'll notice is there's 4 points for printing your name out correctly. And it's formatted and all the stars are correct. Okay? So that's 20% of the assignment right there. I don't know why that shouldn't say 74 points. We used to have a report, but you don't have to do a report anymore. Lucky you. Logic of the code. Okay, so basically, is it logical? Does it make sense? Inputs and outputs, are they handled incorrectly? So this is your scanfs and your printfs. Your documentation is worth 20%. Excellent to reasonable is a difference of 10%. Okay? And we are going to be quite strict on this because this is where we can see your understanding. Okay? And it is expected to be excellent. Okay? So if it's reasonable, you'll get 10. If it's excellent, everything is accurate, everything makes sense, it's well documented, you'll get 20%. Now with this, if you write a comment for every line of code, that doesn't mean you'll get excellent descriptions, and actually it's a bad thing. If you write comments like, declared a variable called step size of type int, that's a bad comment, okay? You've implicitly documented it by writing int x. You've said what this variable type is, you've said what its name is. You do not need to write a comment for that, okay? That's bad commenting, right? Explaining what you're doing, okay? Here we're declaring pi to 6 decimal places. May be a better comment, just to explain that you're using 6 decimal places, and then you might specify why you're using those 6 decimal places. Then when you've got significant lines of code, so why you're using this formula, how you're using this formula, why the for loop is going from this point to this point, etc. Anything that isn't obvious, anything that's implicitly documented, such as creating a variable or an if statement, you don't have to write, this is an if statement, okay? That's a bad comment. But if you write, checking if the value is valid, that's a better comment than this is an if statement, okay? Formatting of the table, okay, that's just your format specifiers. Are the values produced correct? Okay, there is a huge difference between these. Okay, same with the step sizes. Are they correct? Okay, once again, pretty big difference. Indenting. If it's not indented, you get 0. If it's indented correctly, you get 4. If there's some errors, you get 2. Okay, a single error in indenting will get you 2. There is no reason at this stage why you should have any indenting wrong. Okay, Notepad++ does it for you if you let it. Okay, are variables named appropriately? If you give names like step size as SS or something similar, or radians as R, you will lose marks. Okay, the variables need to be suitably named such that you are implicitly documenting. Last thing is, are all variables types suitable? Now that's easy marks because really in this one you only need floats and ints, as we discussed earlier. Is there any questions? Just put it in the chat. A little bit longer, but I think we've covered mostly everything without giving the whole assignment away. So I'll just let you put in the chat. variables. If yeah, what's your question? All right. What's the problems with Notepad++? All right. So lastly, is with the assignment, just make sure that on LMS you do this agreement, and you do read it, and then you submit your code here. Okay. The bonus question information is here. Okay. It needs to look exactly like this. Okay. It has to pass all the cases here. Okay. One fails, we get 0 for the bonus. Okay. Right. There are no partial marks for bonuses. It has to work for every single case, and if it doesn't, then you're better off just removing it or commenting it out. And if it wrecks your other code, you're definitely better off removing it. Okay. The other thing is that you can't get above 100%. And then you've got this hint for comparing floating point numbers. You might find this helpful for your for loops. Any other questions? I think we've got everything covered. What I'm going to do is I'll take a 5-minute break, and if anyone comes up with any questions in the meantime, then I will answer when I get back. So I'll give you a chance to think about whatever questions you want, or write them up. I'll be back. Okay. All right. It appears that there's no more questions, so we might stop there. If anyone has any quick questions to finish off. I don't think so. All right. Well, thank you very much, and good luck with your assignment. I think that gives you pretty much everything that you need to finish it off and do it correctly. Obviously, the commenting and everything else is up to you. Good luck.